NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new.
When the James Webb Space Telescope turned its gaze toward Proxima Centauri, Earth's closest stellar neighbor, the scientific community held its breath. Orbiting this small red dwarf star just over 4 light-years away is Proxima B, a rocky exoplanet that has long tantalized astronomers with the possibility of habitability. At just 1.17 times the mass of Earth and located in the habitable zone of its parent star, Proxima B has stood as a beacon of hope in the search for alien life and a potential second home for humanity. But when the James Webb Telescope delivered its latest observations, the results were nothing short of a stunning nightmare for those hoping for a peaceful, Earth-like twin. Rather than a welcoming world, Proxima B revealed itself as a scarred, hostile planet undergoing a brutal cosmic siege. Before we start, smash the like and subscribe buttons for more updates. The James Webb Space Telescope, equipped with instruments of unparalleled sensitivity and precision, brought into focus details never before glimpsed. As its infrared eyes scanned the planet, it became immediately apparent that the surface of Proxima B is anything but calm. One of the most startling revelations was the detection of extreme atmospheric stripping. High-energy radiation from Proxima Centauri, particularly its frequent and violent stellar flares, had left the atmosphere of Proxima B in a state of chaos. The data showed ionized particles in the upper atmosphere fleeing into space, forming a weak and patchy exosphere rather than a stable envelope capable of supporting life. These findings confirmed the worst fears many planetary scientists had long suspected. Red dwarf stars, while being abundant and long-lived, are notorious for their violent flare activity. Unlike our relatively placid sun, Proxima Centauri regularly emits bursts of radiation so intense that they would fry unprotected electronics and obliterate any semblance of an ozone layer. Webb's instruments caught one such flare in mid-eruption, a coronal mass ejection so massive that it could have stripped away years' worth of atmospheric gases in mere minutes. Observing this event in real time cast a sobering light on the kind of challenges any atmosphere must withstand to remain stable on Proxima B. Even more unsettling were the infrared signatures captured across Proxima B's day-night terminator line. There was no meaningful thermal contrast between the two hemispheres. Normally, a planet with an atmosphere would show temperature gradients between its sun-facing and dark sides. But in this case, the data pointed toward a planet that was nearly uniform in temperature, an indication that there is likely no substantial atmosphere left to circulate heat. This suggests that any early hopes for Earth-like weather systems or even cloud formations were optimistic at best. Instead, Proxima B may more closely resemble Mercury, scorched, barren, and dead on arrival. Adding to the grim picture, Webb's data picked up spectral features indicative of oxidized surface materials, hinting at relentless exposure to charged particles and solar wind. The surface seems to be etched by years of bombardment, possibly with the same kind of photochemical reactions that occur on Mars, but on a much more aggressive scale. There were even potential signs of glassy silicate particles, possibly formed from surface materials melted by intense radiation or micrometeor impacts. The planet's terrain, though not yet directly imaged, might be a bleak expanse of glass-like crusts, wind-swept dust, and radiation-baked rock. Perhaps the most disheartening aspect of Webb's observations was the silence. Utter, unforgiving silence in the electromagnetic spectrum. There was no sign of technological interference, no anomalous signals, and no hint of biosignatures. Even the biomarkers that might indicate microbial life, such as methane or oxygen in equilibrium with carbon dioxide, were completely absent. Proxima B in its current state is not just lifeless, it's anti-life. The conditions are so hostile that the very chemistry needed for life appears to be fundamentally disrupted or outright prevented. Webb also confirmed that Proxima B is likely tidally locked, with one hemisphere eternally facing its star, while the other remains in perpetual night. While some had speculated that this might create a temperate twilight zone where life could thrive, the new data painted a darker picture. Without an atmosphere to moderate temperatures and circulate gases, this strip of twilight may be little more than a dead liminal space, suspended between fiery desolation and frozen oblivion. The idea of a temperate ring brimming with microbial life now seems far-fetched, even laughable. Even more perplexing was the detection of intense auroral activity. The emissions recorded were far stronger than those seen on Earth or even Jupiter, indicating a brutal magnetic interaction between Proxima Centauri and the planet. This suggests that Proxima B might have a magnetic field, but if so, it is either too weak or too overwhelmed to offer protection. Instead of shielding the planet, this magnetosphere might simply be amplifying the devastation, funneling stellar radiation into charged particle storms that batter the surface. This deluge of shocking revelations didn't just concern Proxima B as an isolated case. It also cast a long shadow over the entire category of red dwarf-hosted exoplanets. For years, red dwarfs have been viewed as promising candidates for life-bearing worlds due to their longevity and prevalence. However, the Webb telescope's close look at Proxima B suggested that this promise might be deeply flawed. If the most Earth-like candidate in our nearest stellar system is this damaged, then what hope exists for more distant red dwarf-orbiting exoplanets? The implications of this discovery sent ripples through the scientific community. It forced a reevaluation of what it truly means for a planet to reside in a habitable zone. No longer can habitability be measured merely by distance from a star and average surface temperature. The new metrics must include stellar activity, atmospheric retention, magnetic shielding, and long-term stability, factors that Proxima B fails to meet in almost every category. It also urged scientists to widen their focus, perhaps moving their attention away from red dwarfs entirely, and looking toward more stable, sun-like stars despite their relative rarity in the galaxy. More fundamentally, these revelations triggered a psychological shift. Proxima B had long been a symbol of cosmic optimism, the idea that Earth might have a neighbor just a few light-years away, where life could potentially flourish, had buoyed dreams of interstellar travel and inspired everything from speculative science to science fiction. Webb's findings didn't just destroy those hopes, they did so with ruthless clarity. The romanticized vision of a lush, forested Proxima B has now been replaced with a cold, exposed rock drifting under the weight of lethal radiation. Yet amidst this cosmic nightmare, there remains an undercurrent of awe. The fact that we can now peer so deeply into the secrets of another world, shrouded in darkness across the void of space, is itself a triumph of human ingenuity. The nightmare that Webb uncovered is not a failure of science, but a testament to its power. We are no longer guessing what alien worlds might look like. We are seeing them for what they truly are. The data from Proxima B also highlighted the limitations of early detection methods. Much of the initial excitement surrounding the planet stemmed from its placement in the so-called Goldilocks zone. Not too hot, not too cold. But Webb's findings clarified that such classifications can be dangerously misleading. The Goldilocks zone is a gross oversimplification that ignores key dynamics, especially in high radiation environments. By revealing what lies beneath these shallow metrics, Webb helped redefine the parameters for identifying truly habitable worlds. Some researchers have proposed that Proxima B might once have been more Earth-like. If it formed with a thick atmosphere and abundant water, it may have enjoyed a brief window of habitability billions of years ago. But that possibility only deepens the tragedy. The image of a once vibrant world slowly stripped bare, eon by its violent parent star is not only haunting, it's a chilling reminder of the delicate balance life requires. In a universe governed by radiation, pressure, magnetism, and inertia, that balance appears to be incredibly rare. Webb's observation mission also sparked new discussions about future exploration strategies. Should humanity ever reach the point where interstellar probes or even crewed missions become possible, Proxima B may no longer be at the top of the list. Its proximity is no longer enough to outweigh its hostility. Instead, the search may intensify for planets orbiting calmer stars, perhaps G-type stars like our Sun, or even more stable systems in distant reaches of the galaxy. Proxima B, once a candidate for colonization, may now serve as a cautionary tale. The technical triumph of Webb cannot be overstated. It not only captured snapshots of this desolate world, but did so with such clarity and depth that entire models of planetary science have already been rewritten. In every pixel of data lay a revolution in understanding, a transition from speculation to insight, from hope to knowledge. Proxima B may be uninhabitable, but it has become one of the most important case studies in the field of astrobiology and planetary evolution. Even as disappointment settles in over the findings, there's a strange comfort in knowing Proxima B is no longer a blank canvas for wishful thinking. It is now a defined world with its own violent character and story of loss. It's a graveyard of hopes, yes, but it is also a monument to the power of exploration. We asked what was out there, and now we know. That knowledge, however bleak, is a gift. The nightmare revealed by the James Webb Space Telescope is not a dead end. Rather, it is a turning point, a moment when humanity stops dreaming blindly and starts searching wisely. Proxima B, with its scorched skies and lost atmosphere, has become the frontier of a new kind of scientific maturity. It tells us with brutal honesty that not every neighbor is a friend, but it also urges us to keep looking, to refine our tools, and to sharpen our expectations. In the grand scale of cosmic history, Proxima B's fate may not be unique. It could be a common outcome in planets orbiting the most abundant stars in the galaxy. If that's the case, then Webb's nightmare unveiling is not just about one planet, it's about billions. The search for life, for refuge, for understanding has just become harder. Proxima B showed us where not to look, and in doing so, brought us one step closer to finding the places where life might actually thrive. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on James Webb's nightmare finding on Proxima B? We want to hear from you. Thank you for watching and see you next time.